No questions, huh? Okay. Uh, there are how many examples here on this page? There are two examples on this page. Now, both the two examples, they are about forces in equilibrium, or the two forces, they are at equilibrium. Now, at equilibrium, that means the object is not moving. Equilibrium means stable, stable. They balance one another. The object is stable. They are not moving. So, we are going to look at the cases where the forces, they balance one another. Okay. So we try to find out the magnitude of the forces at equilibrium. Okay. The case number one is there is one person here is pulling the wall, and then the case number two, they are pulling each other, and the force that is exerted by the man on the right is F. In the second case, the force exerted by the man is also F. So the man is pulling with the same force. The size of the force is the same. First case, he's pulling against the wall. Second case, he's pulling against another man. But in both cases, the man is not moving. In the first case, when he's pulling against the wall, he used a force of magnitude F. The wall is not moving. In the second case, he used the same amount of force. The magnitude of the force is F. But this time, he's pulling against another man. Okay. So these are the two situations, right? So can you read this question here? Figure
A
4.3.
person pulls a force with a magnitude F on a scale attached to a wall. Two people pull with a force of magnitude F in opposite direction on a scale attached between two ropes.
Okay. In the first case, a person pulls with a force of magnitude F on a spring scale attached to a wall. If the man is pulling with a force of F, it is recorded in the spring balance here. It is recorded in the spring balance. And if the wall is not moving, that means the scale is also not moving, the man is also not moving. But it doesn't mean that there is no force. It means that whatever force that is exerted by the man, F, is balanced by the force exerted by the wall, but in the opposite direction. Okay? The magnitude has to be the same so that they balance one another, so that everything is not moving. It is at equilibrium. So we say that the force exerted by the man is the same as the force exerted by the wall, and it is recorded in the spring balance here, right? And all the three forces, sorry, not all the three forces, there are only two forces there. The F, the green color arrow, and the F, blue color arrow, exerted by the man. And this size is recorded in the spring balance. Okay, so the in the second case, two people pulling with forces of magnitude F in opposite directions on a spring scale attached between two ropes. or it means that actually the man is pulling the rope. The rope is attached to the balance. The second man is also pulling a rope. The rope is attached to the other end of the balance. If both of them they are not moving, that means the two forces are the same. These two forces, they are transmitted along the rope. So the tension in the rope, one side is F. The tension in the rope on the other side is also F. The two forces, they balance one another. That is the reason why the balance is not moving. The spring balance is not moving. So they ask, okay, the question now, consider the two situations shown in figure 4.30, in which there is no acceleration. So both cases, there's no acceleration. It is not moving with acceleration, neither is it moving with constant velocity. It's not moving at all. In both cases, the man pulled with a force of magnitude F. Is the reading on the scale in part 1 of the figure greater than part 2? Or is it less than part 2? Or is it equal to the reading in part 2? Now they are comparing the two diagrams. It is not within the same diagram. Within the same diagram, of course, we know the blue arrow and the green arrow, they are exerting a force of F. This is recorded inside the spring balance here. The spring balance also show the force of size F. But he is asking, the question is asking, what is the reading recorded in this spring balance here and the reading recorded by the second spring balance? The question is, are they the same? Is one bigger than the other? We cannot see the scale balance. But when I look at this man here, if he is exerting a force of F, of course the spring balance will show F. I look at this man again in the second diagram, he is exerting a force of F. Of course, this F will be recorded in the spring balance. Now, if both cases the man exert a force of F, so in both cases, the spring balance must also record a force of magnitude F. So both the reading in diagram number 1 and diagram number 2, they should be the same. Okay, so the reading are both equal to F. Why? Because the man exerted the same amount of force in the first case and also in the second case. And this force is transmitted equally in the ropes. Any question on this equilibrium here?
No question, sir.
No question. Okay. We are going to look at the one more example, and this time it involves numbers.